All right, so now we're looking at graphs of trig functions. So this is kind of just an introduction in this course. Next year in Math 30, you will spend a whole lot of time on graphs of trig functions. So we're going to look at sine, cos, and tan. Basically, we want to graph the graphs of y equals sine theta, y equals cos theta, and y equals tan theta. So your dependent variable is y, and your independent variable is theta. So as theta changes, what happens to y? So you can see here we have a table of values. We've just kind of put it all together into one chart, so sine, cos, and tan, for each of these angles. So we've chosen the special angles. And then here we've actually given you the decimal form, so you don't have to take the time to go through that. But doing the exact values is kind of a good practice for you. So I'm going to get you started. Then I'm going to pause the video. You're going to pause the video, finish the chart, and then you can check. Okay, so things to remember. What some people do when if they can't sort of think about the triangles, I like to think about basically when you have just do a quick 30, 60, 90 triangle. So there's your 30 as a reference angle, and the opposite side to that is the shortest. We're thinking about the unit circle, so radius of hypotenuse of 1, and then root 3 over 2 here. Then you can have your same triangle rotated. So this is 60 here. So then this is the longest leg, root 3 over 2. This is the longest side, it's the shortest. And then you have your 45, 45, 90. So that's going to be root 2 over 2. Root 2 over 2, and this is 1. Okay, so then you can do it from there, thinking about your reference angle. So they'll all be any of these values, positive or negative. Another way that some students do it is they think about the angles. They write out basically the three special angles, right? And then they write down 1, 2, 3, and then 3, 2, 1. The 3's are square rooted, the 2's are square rooted, and then everything is divided by 2. And those are all your trig ratios. So this column would be the sine values. Okay, so this is sine theta, this is cos theta. So sine of 30 degrees is 1/2. Sine of 60 degrees, oh, I put those, switch the order there. Let's put them in proper order. 45 and then 60. So 1/2 root 2 over 2, root 3 over 2 is sine of 60. Then cos of 30 is root 3 over 2, cos of 45 is root 2 over 2, cos of 60 is 1/2. And then remember your tan is the sine value over the cosine. So 1 over root 3, and then rationalized is root 3 over 3. So they'll just put a t there, and this would be 1, and this would be root 3. Okay, so however you can remember them. So there they are, 30, 45, 60. So right away we can fill that in. We've just done it. 1/2 root 2 over 2 and root 3 over 2. Then root 3 over 2 here, root 2 over 2, and 1/2. And then root 3 over 3, 1, and root 3. Now, 0 degrees, remember back from, so that's a quadrantal angle. So 0 degrees is here. If we're looking on the unit circle, right, the coordinates here are 1 and 0. So sine of 0 degrees is 0, because it's the y value. Okay, y value 0 over 1, 0 over 1 is 0. Cos is 1, and tan is 0. Okay, then 90 degrees is up here. So the coordinates there are 0, 1. So sine is 1, cos is 0, and tan is undefined. 1 divided by 0, can't do it, right? So it's undefined. So then 120, so that has a reference angle of 60 degrees, okay? For sine, it's going to be positive, so it's going to be the same, root 3 over 2. For cosine, now cosine is negative, so it's going to be reference angle, again, 60 degrees, so it's going to be negative 1/2. And tan is also negative, so it's going to be negative root 3. Then 135, reference angle of 45, so same values, just whether they're positive or negative. So sine is going to be positive, so all of these will be positive here because they're in the second quadrant. Then cos will be negative, and tan will be negative. Okay, and then 150 has a reference angle of 30 degrees, so 1/2, then negative root 3 over 2, and then negative root 3 over 3. Okay, 180, coordinates there are negative 1, 0, so your sine is 0, your cos is negative 1, and then your tan is 0. Okay. So I'm going to get you to pause, and I'll see you back in a second. I will have all the answers in there. So pause it until you've completed the chart. Okay, so now check your answers compared to the chart here. You can pause it actually and look at the chart if you need a little bit longer. Okay, and then the decimal forms are given here. That's what's going to help you in graphing. So use these when you go to the graph. So if I turn to the next page, you'll see here, use the table of values to sketch the graph of y equals sine theta and cos theta on the grids. It's going from negative 360 to positive 360. So our chart gives you approximate values for the right side of the y-axis, and then you're going to want to repeat them for the left side. Okay, so don't do a whole new table of values. Take a look. Remember, it's cyclic. It's going to repeat itself. So we're going to basically use the same values on the other side. So start taking a look at your table of values if you have it. I'm going to view dual. Let's see, it's pretty tiny when I do it this way, but you're going to want to look at your theta value, so 0, and then let's do sine first, so just this first column, okay, and so 0, 0 is a point. Then 30 degrees, 0.5, 45, 0.71, 60, 0.87, 90, you're at 1, that's the maximum. Okay, so I think I'm going to pause again. You work on it. You pause your video, I should say, and then I'll have the graph up in a sec. Okay, so I'm just going to go back to full screen. Okay, so there's the graph of y equals sine theta. So I plotted all of the points from 0 to 360 from my table of values, and then I joined them up with a curve. So you can see it has one, I call it a hill, and then one valley. Okay, they're exactly the same shape, except in, obviously, reflections. One's above and one's below, and then they're not, they're consecutive. So it first goes up, and then it goes down for the next part. Okay, so then we have to continue that in a smooth curve. So for 0 to negative 360, we're going to go down to the left and then come back up. So it's always y equals sine theta is always what we call sinusoidal. It's cyclic. It repeats itself, okay? Same distance, so one cycle goes from 0 to 360, because so that's one hill and one valley. And then you can see another 360 there. And they're split equally apart, so one hill has a length of 180 degrees, one valley has a horizontal length of 180 degrees. Maximum value is 1, minimum value is -1. Okay, so that is the graph of y equals sine theta. Now we're going to do this. So for y equals cos of theta, we're going to do the same thing. Use your table of values and start filling in the plotting the points, joining them up. I'll start with you. So cos of 0 degrees is 1. Cos of 30 degrees is 0.87. Cos of 45 degrees is 0.71. Cos of 60 degrees is 0.5. Cos of 90 degrees is 0. And then pause your video. I'll complete this and then you can check it. Okay, so there's the graph of y equals cos theta. If you compare them, they are very similar, just in a different location, but their maximum value is 1, minimum's -1. There's a hill, okay, from -90 to +90, so that's a horizontal distance of 180, a value from 90 to 270, which is 180. So really it's just a hill and a valley, but located in different places in each cycle. Okay, so a function is said to be periodic if it repeats itself over regular intervals of its domain. Are these periodic? Yes, because there's a hill, a valley, etc. The period is the length of the interval of the domain over which a graph repeats itself. So easiest to look at sine because it goes through 0, 0. So whereas one hill and one valley, that's 360 degrees. So that's what the period is. Here, if you look at the maximum to the maximum, that's 360. So as long as you get back to where you started in the same direction, you can tell what the period is. Okay, so sinusoidal data is periodic data whose graph can be represented by a wave pattern. So it doesn't mean that there aren't other types of sinusoidal graphs that aren't y equals sine theta and y equals cos theta, but basically these are the primary ones because that word comes from it, right? So these are sinusoidal, of course. Okay, the domain of both graphs, well, this goes on forever. So the domain, was this x or theta? This was theta. So the domain here is all values of theta, where theta is an element of the set of real numbers. Okay, so the maximum value we talked about is 1 and the minimum is -1. So that means the range is between those values. So remember, I put the lowest, highest, and then in between y, and then my inequality sides. Okay, so next is tan. It's a little bit different. So again, we're going to start with some values that we do know. So tan of 0 is 0. Tan of 30 degrees. So go back, and again, I'm going to get you to pause it in a sec. Tan of 30 degrees is 0.58. Tan of 45 is 1. Tan of 60 is 1.73. So they're all going to be either positive or negatives of those. Okay, so 0.58. Now notice the scale here. So this goes up by ones. So 0.58 is going to be about there. And then 45 degrees is going to be 1. Then 60 degrees is 1.7 something. And then it's undefined at 90. So what you want to do right now is put an asymptote in there. So I just use this dotted line. Asymptotes we usually use dotted. It doesn't have to be quite this thick, but that's going to be your asymptote. Okay, and same, then your next asymptote is at 270. So I'm going to put that in right now, right? Makes it easier. Then similarly, you're going to have an asymptote at negative 90 and negative 270. Oops. Give me a sec there. Okay. Let's move that over a little bit. So those are your asymptotes. So your graph then, when you go back in here, so this is going to approach it, but never touch it. Okay, and then if we do the negative direction, so that's going to be negative 0.58, negative 1, negative 1.7. So it kind of does what I call a zigzag through. Okay, so there's one cycle. Okay, important things, or things that I like to remember with the tan graph, is halfway in between the asymptotes. Oh, actually this asymptote is a little bit off here. Sorry, just give me a sec here. Oh, this should be over, I was wondering, because the graph doesn't look great. Okay, there we go. There's at negative 90. So now I can make my graph look better. So negative 1, negative 1.7, and then it approaches. Okay, so the shape is the same on either side, but just it's a rotation basically. So it zigzags through. So the biggest things to remember, because you may not want to draw every single point in there, but the what we call the point of inflection, where it changes, does that zigzag, is halfway in between the asymptotes, and then halfway in between that zigzag, we call it the point of inflection, and the asymptote is the point where the y value is 1. That's going to help you more next year when we get into transformations of these. And then halfway here is at negative 1. So at least you can get those 2 points, even if you don't remember what the decimals are for the value of tan. Okay, so pause your video. I'm going to fill out the rest and then you can check it. Okay, so you can see you have 3 complete cycles in there and then partial ones at the ends. So I put arrows on the end as they approach the asymptote, but they're never going to cross those asymptotes, because remember there is no value when the angle is 90 degrees, 270 degrees, etc. So this is cyclic as well, but it's not considered sinusoidal in that it's not continuous. You can't continue to graph the whole thing without lifting your pencil. All right. So is it periodic? Yes. Okay, because it does repeat itself. And what is the period? Well, now that pattern repeats every 180 degrees, from negative 90 to 90, from 90 to 270. So different from sine and cosine. Why is it not sinusoidal? Well, it's not continuous, right? Oops. Continuous. Okay, you have to lift your pencil. There are asymptotes. Okay. What's the range? Well, the arrows go up and down. So the range of this is all real numbers. Now, the graph has vertical asymptotes at what values? So where theta equals, so here negative 270, negative 90. So negative 270, negative 90, positive 90, positive 270 on this graph, but they would repeat, right? So now we want the general expression. So what's happening here? So general expression, I always look for the first positive, okay, which is 90, and then what do we keep adding? we keep adding 180 or subtracting. So that's where we add 180 degrees times n, where n is an element of the set of integers. So for IB language, we use the z. For normal Alberta, we use the I. So the domain, then, if those are the asymptotes, now our domain is everything except those. So all values of theta, where theta is not equal to 90 plus 180 degrees times n, an element of the set of integers. Okay? And that's it.